Hey, what's up? It's Joe back with a SQL video. This video is going to talk about different select queries that you can use. It's going to start off very beginner, then get to some intermediate stuff, and then touch on a couple of advanced stuff. Not too much, just a little bit. This is based on Microsoft SQL, but I feel like most, if not all of these commands should work on other ones like Postgres and Oracle and MySQL. They probably just work across the board, but this is based on MySQL. This is based on Microsoft SQL. And with that being said, if you're liking these videos, go ahead and subscribe and hit that bell to get those notifications. I do plan on releasing these videos every 2 to 3 days. Why? Because I am learning a lot by doing it, and I actually enjoy doing it, and I think it's fun. If you have any questions or concerns, always just hit me up in the comments, and I'll try to answer them as quick as I can. So what we're going to do is first see the database that I'm using. Okay, this is the database. I will put the link in the description. So it's just this site, dofactory.com. They have a sample database. There's only 5 tables. If you go here, you can download the database or download the scripts. You're going to have 2 scripts here. One script actually creates the database and creates the tables, everything that you need. And then the second script has a script to actually insert all of the data. So these are the different tables that you would have. You have a customer, order item, product, and supplier. Just to go through this real quick, a customer could be you. You're going to have a customer ID, first name, last name, city, country, and phone. And then the order is just basically something that you or the customer is like buying. So you're going to have an ID for that order. You're going to have an order date. So like what date you buy the order on, an order number, a customer ID, which basically says that I want to know which customer bought this order. And this FK means foreign key. So it references back to this customer. What that means is that every order has to have a real customer attached to it. If this customer ID does not exist inside of this table, then that order is not valid. Like you can't insert into that table if it doesn't exist, if that customer ID doesn't exist. Now every order, this can be like something, say for instance, you're going to the grocery store and you buy like 20 items. And you have your overall order, but then you have the order items, which will represent the 20 items that you just bought. So that information has an ID. It has an order ID, which references back, that foreign key references back to the order table, basically saying that every order item has to have a real order attached to it. And then you have a product that's basically saying that, every order is an actual product. And that points to this product table. And you also have unit price and quantity inside of this order item. And then the product table, it's just telling you about the product. So you have your product name, you have your supplier ID, your unit price, your package, and your is discontinued. Now the supplier ID is basically saying, okay, I have this product, but who supplied it? So you have to go back here. This supplier ID is a foreign key to the supplier table. So every supplier in here has to be a real supplier to be inserted into this table. And the supplier has the ID of the supplier, the company name, contact title, city, country, phone, and fax. As far as the indexes, we're not going to look at that because that's outside of the scope of this video. This is just basically about doing selects. And I am assuming that you already know how to set up the database, whether it's local or something you're like remoting into. And also I'm assuming that you already have something to use to write queries. Now what I'm currently using is called DataGrip. I actually just downloaded it maybe like 4 or 5 days ago. I've actually fell in love with it. It's not cheap, I will say that. And I'm not trying to tell anybody to go out and buy it, but I have like a 30-day trial, and I'm probably going to end up buying it because I have actually really fell in love with it. It does a lot. But you can also use SSMS from Microsoft, which I actually don't think that's free either. But if you do want to take the free route, you can use Visual Studio Code, which has a plugin for SQL that you can use, and you don't have to worry about paying for an actual like management studio to start writing all your queries. And there's other ways you can get around, but those are like the main 3 that I can think of at the moment. So let's go ahead and start this with some beginner stuff, because I said this will start off very beginner. So what is beginner? Let's just say select 1. Okay, so I just selected 1. That's extremely beginner. It says anonymous here because I didn't give it a column name. So let's say I want to do an alias. That's like giving a name for it. So I can say something like this as just to say C for now. So you see it gave it the C. I can also do something like this and say still as a C, but this is probably more cleaner syntax with the brackets. You can also just get rid of this and don't even do the as and just do it as that, and it still works. Or you can actually just do it without the brackets as well, and it still works. So there's different. It's your options. You decide how you want to write it. A lot of times it depends on where you work. If you're like working and you're doing this stuff, they have a certain style they want you to follow, and you should follow that if they have that style. And if you're doing it like at home or just for fun, just kind of do whatever you want and see what stands out to you. So I selected one, and let's say I select the string. That's a string there. Let's say I can select null. Okay, I select null. So let's say I want to start selecting from some tables. Let's just go back and see the tables again. We have the customer table, supplier, order, product, and order item. Let's just use let's just use supplier for now. It shouldn't be that many records for a supplier. And to select from a table, we're just going to start with the basics. So select all from the table. So you select whatever you want to select. Star means all, so I'm selecting everything. And then from is saying I want to select from something. So supplier is the name of that table. So if I do select all from supplier, excuse me, I'm selecting from that table, and I have 29 records, as I can see here, 29 rows, and these are just all the different data points. So if I want to actually compare that, just so you can make sure I'm not making this stuff up, if you look at the supplier, it has an ID, which is here, the company name, contact title there, city, country, and then phone, and there's also a fax over here. So it has all of the different things that it should have that was said to be in that table. Okay, so now that I've selected all, say for instance the only reason I knew I had 29 records because I looked at the results and I saw it said 29 records, or I looked up here and it said 29 rows. So let's say for instance I didn't want to do it that way. Say for instance I wanted to count. So you can actually count the number of records inside of a table by doing something like this. It just says count star from supplier. So counting the records. You can also do count one, which is going to give you the same result. But count one is actually faster for SQL to do the work than counting star. So if you're just count the records, I would just say use one, and it's just going to still count them the same way. Okay. So let's just go back to all so we can see everything in the table. And now let's say we want to start adding filters. So filters you add with a where clause. So this is something like when you're going on like maybe like Amazon website or Walmart or any kind of those websites, and you start looking at stuff to buy. You want to filter by the price and filter by the brand. This is the exact same thing. You're putting in a where clause because you want to do a filter. So in this case, I'm going to look at my 29 records. I'm going to say I want to only get the records that has a country that is in USA. So I can say word country because country is a column name, and I can say USA. Okay, so that is the USA, and then this only return 4 results. And as you can see, I have my country equals USA. Everything else was filtered out. And let's say I want to even take this deeper. Let's say I also wanted the fax, which is here, is to not be null, meaning that I want some kind of data to be there because these two are null, so I want some real values. And real values can also be, if this was a string, a real value could also be just empty string, like just nothing. But it's still like kind of like nothing, but null means really like it's nothing. So when I run that, I see I have these 2 records here because I said and fax is not null and USA, and the only 2 records that meet that criteria is record number 3 and 19, where the country is USA and the fax is not null. And let's say I want to take it even more. Let's say I want the city to equal, let's say Boston. Okay. Now in this case, I only get one result. Reason being because there's only one record inside of the supplier table where all of these 3 things actually met, where the country is USA, the fax is not null, and the city is Boston, as you can see here. Okay. So let's just say I want to use like an R. Well, before I do the R, let's just look at the N again. So the N gave me 2 rows because it's USA and it's not null. So say if I want to do an R. Now I have 15 rows. So I went from 2 to 15 just because I changed from and to R. So you kind of see, like, if you're new to this, that like just changing certain parts of your statement will give you completely different records. So you have to know what you're looking for. You tell what you want and it brings it back. So just keep that in mind. So now I'm saying R. So now I'm saying the country could be USA, which is, as you can see here, or the fax is not null. So in here the country is USA, but the fax is null. But it doesn't matter because it's USA. And here I'm saying the country is USA and the fax is not null. So one of those criteria is meet. Here the country is not USA, but the fax is not null. And that's why I got a result here. And if I were to go down, they'll all end up passing the same way. They'll pass either both or pass by one. But one of these have to be met to be able to be in that result set when I use an R. Okay, so let's just say if I want to do something, let's say city. So let's just do city like. So like it's a different thing that you can use. So like you can use on strings. So if I just do, so like has these two characters. It has a percent and has an underscore. Percent represents any character, any number of characters. Underscore represents one character, but it could be any character. So for instance, if I did this and just said like percent, I'm getting all my 29 records back because I'm saying it's like this. I want my city to be like anything. I don't care. But say for instance, I did the percent and I said I wanted to have, let's give it, so I want it to be anything and I want it to have a K. Oh, actually, I need to add one here too. So basically what's happening is I'm saying that I can have any characters before K and any characters after K. So if you look here, I have Tokyo, there's a K there. I have Osaka, there's a K there. I have Frankfurt, there's a K there, and so on and so on and so on. Now if I did something like this and I took this out, we got no results because this is saying that it must start with the K and then I don't care about anything afterwards. So that wouldn't work. So let's say for instance I said okay, it can be any character and then have a K there, and then after the K I want it to be an A, and then I still don't care what comes behind it. So here I'm saying it can be any characters to start with. I have to find a K and an A. There's a K, there's an A, there's a K and an A. And I don't care if there's anything behind it, any number of characters, any character, like I don't care. Now say for instance I took this out and I run this again, or they both end with K, so that'd actually be the same. But let's say for instance I put like an I here. Oops, not that I. And now we're saying that it can start with any characters, and I have the IKA, which is here. It ends with IKA. Okay. So let's also look at like between. So let's say we said where ID is between 1 and 4. So if we look here and the supplier, this is a supplier table, we're saying ID between 1 and 4. This is inclusive, so it includes the 1 and includes the 4. So 1, 2, 3, 4. I can also say ID is what I want to do, greater than 2. So it's going to be everything above 2. So you see it skipped 1 and 2. So it has a 3, 4, and so on. I can say ID less than 10. So now it has everything that's less than 10. You can just play around with different things. Let's also touch on some strings. So let's just go here. So these are different strings that you can use. I've already been playing around with some before I started this video. Like I've used them before, but I just wanted to click on them and look at the documentation to see how I can explain how the documentation works. So let's just say, for instance, let's just try one that I haven't used. So let's just say trim. What does trim do? And by the way, this is on the Microsoft website, docs.microsoft.com, and then takes you to this like SQL functions and stuff, you can also go from here, and then you just click on it. So trim. So trim does what? It removes the space character or other specified characters from the start and end of a string. Char 32 is a space character. So basically what it's saying is it's just going to remove all spaces. Okay. So the trim actually just takes like a string of characters. As you can see here, it just takes a string. That's the same thing. This is for Azure and this is for SQL Server, and it pretty much works the same way. So if I was to not even use a table, okay, let's say if I want to just say select, and let's say if I have something like this. Now currently if I select that, you're going to see the different spaces that are there. But if I said I want to trim it, it took the spaces out, and it also took the spaces off of this side. You just can't really see it because this is so long that it looks like it's spaces there, but it's really not spaces there. That's just like using trim. And let's just say we wanted to do like let's try len. What does len do? Len returns the number of characters of a specified string expression excluding trailing spaces. So if we were to do this, oh, I can't type again. So it's saying 8. And if we were to count this, 1, 2, 3, 4, 5, 6, 7, 8. It's not counting these because if you remember the documentation, it said that it excludes trailing spaces. So the reason why I'm going back and forth between the documentation, because I want you all to get used to using documentation. Nobody remembers everything. I am not even close to remembering everything. I have a lot of languages in my head, a lot of stuff I try to do, and I can't remember it all. So I always go to documentations when I need to figure out how something works. So if you can master the art of reading documentation, you're really going to take your development and your development to a completely different level. Because if you can read documentation very well and understand it, it tells you everything you need to know to come back and write the code. So just get good at reading documentation and you're going to get better regardless. Okay. So let's just try one more string before we move on. Let's just try upper. Okay. So here we're saying that, and that's just going to take everything to uppercase. And if you want to see it do, oops, what am I doing? Say lowercase, then just change it to lowercase. So you can just see the different ways. So right here, I'm just doing everything from like a single statement. I'm not even using the table. But the reason I did it this way, because I want to show you that you can actually do all of this stuff without having to use a table to do it. You may know that and you may not. So with that being said, is once you start playing around with this stuff, you can test stuff out before you actually get to the table and see all that extra data that you may not want to play around with. So now when I do that, I can say select all from, let's just say supplier again. And what was one that I used? Let's just say we're going to just uppercase all of the company names. So we're going to just keep that here. That selects everything, but we can also add a different column outside of selecting everything. So we can just say upper company name. Okay, and let's just give the company name an alias so it doesn't say anonymous. So let's just call it uppercase company name. And let me also format this to make it look better. And as you can see, it has this column, which is the uppercase company name, and then the upper, and now everything is uppercase, as you can see here. And if we were to do the same thing, we can do it with the lowercase, and it will work the same way. That name is wrong, because it shouldn't say uppercase anymore. I should change that. And you can also do it with len. Let's just take off this name so it doesn't get really confusing. So this is just counting the number of characters. So 1, 2, 3, 4, 5, 6, 7 because of the space, 8, 9, 10, 11, 12, 13, 14. That's 14 characters, and so on and so on and so on. Okay. So some other stuff you can do by reading the documentation is you can play around with dates. Okay. So let's see. There is this stuff for conversion, and let's say cast and convert. This is how you change the data type to something else. So say for instance, you can format stuff this way, and you can also change like data types. Maybe you want to change a string to a date. Maybe you want to change a number to a string. Just to show you some stuff with cast, okay, before we get too far. Uh, so let's say if I want to select 1, right? Currently that is a number. But if I want to say select 1 and then cast it as a string, which is meaning varchar, I just put 10. I could just put 1 there. But this is just the length of the string. So now this is actually a string. So to prove that this is a string, let me just show you. So say for instance I did select 1 plus something like that. That's gonna fail because I cannot add an integer and a string. It doesn't work like that. It's just gonna give you an error. But I could cast this 1 as a string, which is what I did before. Let's just say 1 this time. And then now when I add it added the 1 and then put the AS, all of that attached to it. If you want to see it this way, just to make it easier to see, now it has that. So you can use the same logic when you're selecting columns from different tables. And along with that, there's also this other thing called convert. So convert, you can actually like do a lot of built-in stuff that it has. You can convert it to a string, and then if it's like a date, these are different dates formats that you can use to spit out your date in different ways. So let's just play around with that. Let's just find a table that has a date. So let's see here. Supplier, product, order has a date, which makes sense because you have an order date. So let's just use that. So first, let's just say select all from order. Okay. Oh, okay. So I got this error because order is actually a keyword. I'm glad it happened, so I can show you. So it's a keyword, right? So that's used when you like try to order items by like ascending or descending or order by a different column, which I'll go into more of that in a second. So what I need to do is actually put these brackets around it so it knows that it's no longer a keyword. It's actually the name of the actual table. So if I select all from order, it's going to give me a bunch of records, 501 plus, which means that it's more than 501. If we want to see how many records there are, which we looked at this before, there's 830, and we can also do it by 1, which is actually better. There's 830 records, okay? So my whole reason for going in here was to look at dates. So we have an order date. And as I said, you can do these things not just on single commands, but do it on the actual columns, which is when it becomes like, that's when you get into the real power of SQL. One of the things you get into the real power of SQL, because there's so much more. So let's say I want to go ahead and get everything, but I want to also add in the order date, but I want to convert it. So let's first just to see what the order date gives. That's the order date. Again, you get it here because I'm selecting all. So I'm getting the order date and then everything that's in the table. So if I want to say convert, so I'm going to convert this date to a string, and it's going to be a date, and I'm going to just say, let's give it 120 or something. And I need to spell convert right and format it. So as you can see, it converted the, oh yeah, probably should give it, let's say varchar. Why is this complaining? Yeah, I need to give it like a length. Okay, so it converted that date, and as you see here, let's just see. So you have your convert. This is the data type. This is like the documentation again. We're back in. First, I did the cast. I said cast whatever the expression was when I did the number, and I said as a data type, which was a varchar. How I converted the 1 to a string, and then for the convert, it takes the data type first, which is what you saw here. I'm saying convert varchar 20. I'm giving a length of 20, and then I'm saying the expression is going to be the order date, and then the style is going to be 120. So if I look down here, I have different options. So let's say, for instance, I wanted to do 107. 107 says it's going to do something in this format. Okay. So let's just change this to 107. July 4th, 2012. So it changed the format. And let's say I use 7. It's going to take off, won't have a year, just do year. So as you can see the 7 here. Okay. So let's just take that off. And now it says just 12. It doesn't have the 2012. Okay, so that's just how you can do like with changing stuff from like converts and casts, like changing data types. And let's also look at some joins because we kind of skipped over that, or I guess I skipped over that. Let's just see the data again. So we have customer, supplier, product, order, item, order. Let's see what I want to do here. So let's see. Okay, so we're gonna just look at the product and the order items. So this is a good one because not every product that's out there is going to be ordered. Like for instance, if you're again looking on some website trying to order something, just because it's there doesn't mean that it's going to actually have an order associated with it. Now every order item must have an actual product associated with it, but a product does not necessarily have to have an order item associated with it. If I confuse you, let me try to explain. So let's say we have all from product, right? And let's just look at everything from the product. It has 78 rows. These are all my different products. I have like some chai, some aniseed syrup. I have some tofu, which I actually love tofu. And some, a bunch of stuff. Coffee. Yeah, coffee is good too. So let's say I want to do a join. So the way you do joins is, joins, it actually takes two tables and join them together on a column that you want to join on and pulls the information from both. So let's say I'm going to give this an alias, right? Giving it an alias because it's easier to go back and use that product without having to type the full name. So I guess before I use the alias, let me show you without an alias, because let's just do it the right way. Well, not the right way, let's just do it the full this way so you can see how it works. So I said select all from product, join on order item, and then a join order item, I'm going to say on product.id equals order item.product ID. So now if I do that, it's going to give me all of these different things. So this is just telling me all the different products I have and the order information associated with it. So although I only have, I think like it was 78 products, I have way more orders than that. So if I were to look here, I have 2,155 actual, well, not orders, but order items. So there's been 2,155 different items that has been ordered. Okay, so now we have that. So I had to type out the whole product and the whole order item. So what makes this easier is by using aliases. It is good to give these like an actual name that makes sense. Right now I'm just using P and O because P represents product and O represents order item. Probably should use OI just to make it easier. So now it's going to get the same results. You see? It's just now I use the aliases, and just to show you that I'm not making this up, I still get a 2155, the same number of records. Okay. So that was a join. Basically joins and says I need every record. And let's just say we want to get top 5. So I just say give me the 5 top records. So now we're gonna have to look at all those other records because there's just a lot of records. So let's just make the data set smaller. So get the top 5 records. So we have these. So now let's say we want to get records that instead of doing a join, we want to do a left join. So the way left join works is saying that I'm going to look at the product table. I'm going to join the order item, but I'm going to do a left join. So basically mean that I'm going to return every record in the product table. So every record I have in the product table, I want to return back. And then I'm also going to do a left join on the order item. So I'm going to return all of the order items that's associated with that product when it joins on here, but it may not even be associated with it, because when you do an inner join, when I just do this, oops, sorry. Oh, I cannot type, come on. So here, which is the same as taking this out, inner join is the same as doing just join, meaning that they have to exist in both this ID and this It has to be a match. But when I do a left join, it's looking from the product first because that's the first table that I put. So I'm left joining to that table and send order item. So here it doesn't necessarily have to be a match. So let's just take out the top 5, and if I do a count again, this count is probably going to be different. So we have 2156. So why did we get one more record when we did a left join compared to a regular join? The reason being is because when I did the inner join, I said it had to be there for both. The left join meaning that an order item may not have anything associated, well, product may not have been ordered yet, but I'm still going to show you that result. And a way to actually see which one it is, I can do another filter, and I can say where, and I can say OI, which is the order item, OI dot ID is null, which basically means that I want to look at all of the products that don't have an item, don't have an order item associated with it. Right now it's doing a count. Let me just take off the count. And then this order here, see its product, it has all of the information, but this is null. Everything about the order item is null. Reason being because it doesn't have an order item associated with the product. This is why it's showing null. And if you were to do it a right join, it would be the opposite way. So basically it means that if I did a right join, it would say that, okay, well, it has to have an order. I'm going to show all of the order items, but it may not have a product. This wouldn't work in this case because the way that the table is set up, you can't have an order item without a product. But you can do different things with joins and get different information there. So let's also do some other stuff. This is gonna start picking up a little bit quicker here. So let's say we want to just say select all from product again. So we have all of the product stuff. And let's say we want to get the average unit price. Okay, just to say average. These are called aggregate functions. So if I want to get the average unit price, it's going to be this $28.62 blah 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 cents. Okay, so I can also get the min, and it's $2.50, and I can get the max, and I can get the count. Oh, sorry, I can get the sum. So all of them added together. 2232.46. Okay, so now we're getting all this information, but like that's not giving me anything. It's just giving me this one little number. So say for instance I want to get some kind of association with this. So say for instance I want to select the let's say I want to select the sum, but I want to group it by a certain like value. So let's, before we do the group, because I'm new to this table, so I don't remember everything that it has. So let's say we want to group by supplier ID. So now we're in the product table, and we say we want to group by supplier ID. So we want to get a sum of the unit price. Oops. And we're going to say from there, I'm going to say group by the supplier ID. So here we have these, but this is still not really telling us anything. So let's go ahead and return the supplier ID. Now right here, if I do this, now I get the supplier ID. And let's just clean this up a little bit to make it easier to see. And let's just call it sum price. So now it's saying for this supplier, it has a total price of with all of the different items that has been ordered is $47. For this supplier, it's $81.40, and so on and so on and so on. Each supplier is only showing once, but it's actually aggregating the price and adding it together for each supplier. So you can like kind of like make little reports if you're doing like, you know, like working for a job, we have to do like reporting. This is like really cool stuff you can do. Okay, so now that we've done that, let's say we've done this grouping, but I don't really want to see all of the records. I only want to see records of people that has spent more than 50, like record of suppliers that has a total of more than $50. This is where having comes in. So you can say having, you have to do the same aggregate again that you used up there. You can say having that and then put greater than 50. Okay. So now the records drop down to 18, but as you can see, everything here is over $50. And you can also do multiple. You can say and supplier ID is greater than 10 or whatever you want to use. Okay. So now we all have all the ones that are over 50 and all the ones that's a supplier ID greater than 10. And you can also just keep adding on and on like we've done before and just make it more like filtered as you want. So the key thing with aggregates is it basically gives you a way to do some calculation over a certain group of values, and then you'll get back that aggregation to get back the aggregation of what you're trying to do. So if I want to do like say min, right? I say min price, I change it to min. So it's saying that the minimum price for this is here. The minimum price for a supplier ID 11 is the minimum price, which I should change this from sum price because I just got confused. I'm like, what? Sum price. So since I change it to min price, let me just make it actually make sense. So the minimum price is 14. And if I wanted to see this, just to show you that I'm not making this up and that this query is actually correct, I can say select all from supplier where ID equals 11. So this is that supplier. So if I look here, oh yeah, actually I should be looking in the order item table. I'm sorry, in the, what table did I use here? In the product table. And this will be supplier ID. So you can see this supplier table has 3 records here. And here, what did I say here? The minimum price is 14 for supplier ID 11. And we group by supplier ID. Okay, so yeah, and then there's a 14 here. So if you see here, like this supplier has 3 records, and it has a unit price of 14, unit price of 31.23, and one for 43.90. Just gonna go ahead and pin that here so I can keep that there, and then go back and look later, so it's easier to see the results. So let's just say we want to change this to max, and we do that. As you can see, 11 is now 43.90, but if you look here, max, which is the max one, is 43.90. And let's say we want to do like let's just sum them all up like we've done before. I'm just gonna remove this again because it's confusing me. So just gonna leave it anonymous. But 11 has 89.13, and if we look here, if we were to add these all together, that would be 89.13 if you did the math. Because you have your 3, 9, 2, that's 11, put the 1 there, and it's going to be 89.13. Okay, so that's how you're able to use like aggregates to get more information. But okay, so when you're using aggregates, it just takes that information and gives you a result like this. But say for instance, I still wanted to see all of the other information that I've used. I want to know this value, but I also want to know the other information as well. So this is where analytical functions come in. So analytical functions lets you run kind of like aggregation over the entire data set. It doesn't remove records. It doesn't group them like that. You can run them on a group, but it doesn't do the group here. So you're still getting all your results. So let's just turn this into an analytical function, and I can show you. This is where it's going to get a little bit more like advanced. I can kind of show you how this would work with an analytical function. So what I'm going to take off the whole this like here, because I don't need all that. I'm going to take this off. So now if I do this, and if I do this here, right, that wouldn't work because it's saying a sum price and a supplier ID, but to do that, I need to group it by supplier ID for this query to actually work, as you can see here. So, but I don't want to do that because I want to get more information. So what I want to do is say sum unit price, and then I want to say over. And the way over works is it's almost like you're doing an aggregation. It's called an analytical function. It's almost like you're doing an aggregation on all of the records. So this partition by means that I'm going to partition by whatever I grouped on. So if you're like trying to learn how to do this, you can always write like your function like this to see what you're trying to get, and then rewrite it this way. So let me just move this down so you can see everything together. So you can write it like this at first, right? And then start rewriting it this way. So it can say partition by supplier ID. Okay. So now if I run this, I actually am getting more records. So here, when I ran this one, I got 12 records. But here, I got 78. So with that being said, you can actually even do something like this, right? So now I'm getting my sum unit price, that partition, but I'm also getting all of the other records as well. So now I'm getting this first result. So as you can see, these are all the same, 8140, 8140, 8140. Now here, I couldn't get that information. So let me just unpin this for a second because I want to be able to just show you all of this. So we're just going to take this having off, and this is basically all we need. So just do that. And then we're going to go ahead and pin this. And let's just call this sum so we know what's going on. And then we have the sum price and the supplier ID. Okay, and we have 29 records here. So now if we do this, like I said before, we have more records. So if you look here, let's just look at supplier ID 1. Okay, so supplier ID 1 is here. Now supplier ID 1 has 3 different records, and it's still showing all of the other information. So say you get all this information, but you still wanted to know the total, which I guess I should do this because it's just going to be more confusing if I don't, because nobody really knows these tables like this, so you want to kind of see what's going on. So I thought I changed that. Did I not put sum price? I thought I did. Okay, we have that pin, and then just delete that one, and then do, okay, so is that still pin? Yeah. So we have the sum price, right? And you have your supplier ID is 1, and then here's 1. So it's saying the sum price for that is 47, but doing it this way, you're missing out on all the other information that you may want. But when you turn it into an analytical function, you're able to get that same information, but do it over all the records and keep all of the data from all your records. It doesn't remove them. So you have your 4747. If you look here, you have 8140 for the max price. I mean, for the sum of the price for supplier 2. And if you look here, supplier 2 has 8140, but I'm still getting all that other information. So let's say, for instance, now that we're messing with analytical functions, let's say I want to do something like, let's look at customers. So let's just make this more, let's just start doing some cool stuff, okay? So let's look at customers. So let's see what customers has. From customer. All right, so customer has 91 records. So there's 91 customers in this table. And let's say this is what we're trying to do. So let's say I want to group the customers by their first letter in their name, and let's see, Yeah, group the customers by the first letter in their name and see how many customers have that letter. So if we're doing it, let's do it this way first. So let's say select all. Well, not select all. Let's just do this for now. Select all for customer. Let's say you want to do left first name 1. Let's just do that first. See what we get back. We're getting your first name, and let's say we want to do a count. Actually, wouldn't even be here. So let's just say we're going to do a count, and here is where we're going to add the grouping. So group by left first name 1. So, we probably should just return the actual first name and then format that. Oh, and let's also return this. So the reason why this is failing, is going to fail again, is because when you're doing your grouping, anything that's not an aggregate needs to be included inside of the group by. So I'm grouping by the left dot first name, and I also need to group by first name because I'm putting it inside of the select statement. So, and left is not an aggregate, that's why it needs to be there. Left is just a string function. The only aggregate we have here is count. So now when I put that here, I can see the first name here. So I can say, the count of the letter A is, so what am I doing? 5 customers, group by left dot first name. Actually, sorry, I shouldn't be grouping by that first name because that's going to throw the count off. So let's just do this. There we go. When I added the first name, that grouping changed, so it wasn't just grouping by the first letter, it was grouping by the full name, full first name, and since all their names are different, that's why you were seeing like the 1 1 1 1 1. So I just made a mistake there, but glad that you saw it, so you kind of see how this whole thing works. So here I'm saying I'm counting all. So there, what it's telling me is that there's 2 people that don't have anything. They don't have a first name at all. There's 8 people that start with an A, 1 person that start with a B, 5 people that start with a C, and so on and so on and so on. But again, when you start doing this, you're like, well, I want to see the rest of the information. Well, now we only get 21 records, and it's just this stuff. So to be able to do that in the analytical function, so you can start seeing more information, I can just do select all again, so you just see everything, and I can say count. Let's just say count 1. It doesn't really matter. And just say over. We're going to partition by. Which that group is here. Left first name. If you just do the same thing. 1. And I think I have to do order. That works. Let me format it. So if you see here, let's actually go ahead and pin this. Is it already pinned? No. And then let's run this again. Let's pin this one as well. So if we look here, we're saying that we have 2 people that have no first name. As you can see here, the first letter of the name doesn't exist, so they don't have a first name. And if we look here, we can see that we have 2 people that do not have a first name. And we have the 2 here, which is coming. Let me just go ahead and name this. Say first letter count. And that's also, when you do stuff like this, you can add in more information and don't have to worry about it causing errors because it's trying to group by. So you can just literally just add in other columns that you want. So in here, I do want to add in the first name or the first letter so I can just see it. Oh, come on. First letter. Let's format it. So here, as you can see, I have my first letter count and I have my first letter and then all of the other information. So here, there's 2, right? And you can't get all your information with the regular group by. But with analytical functions, you can. I have my 2, and I have all the other information attached to it, so I can still see more stuff. And you can see the number of records are different. This is 91, and this is 21. And then here I have 8. So I say I have 8 people that have a first letter that start with A. And then here, if I look here from the regular group by, which is doing it this way, I have 8. Okay? So I can see all of that and then get more information, and then so on and so on and so on. So as you can see, like when you're doing analytical functions, it's give you access to see all of the information that you're used to seeing in the full table without losing it by doing a group by. Now, this is not saying that every time you want to aggregate stuff, you have to do an analytical function. It just depends on what kind of data you're looking for. That's really what it boils down to. So it's not really that you have to do it this way. It's just if you feel like getting more information, then do it this way. Okay, so let's try another one. Let's say I want to get let's say I want to, what is this? Do I have any other IDs in here? This is customer. Let's do a different table. Let's say, what other tables do we have here again? Let's see what we can do with dates. All right, so, oh, there's that thing again. So let me just change that. So now we have these stuff. We have the order and the order date. So let's do something where we say you want to get the orders by like year. Okay. Let's say you want to do something where we get it by year. So if we were doing it the regular group by, just so I'm doing it this way so you can kind of get used to being able to take it from one way and take it to an analytical function. Normally when I'm writing this stuff, I don't do a regular aggregate and then go to an analytical function. I just write the analytical function. But I feel like it's easier doing it this way to let you see how you can create it, because a lot of times when people start using analytical functions, they get confused on like, how do I do this? But this makes things a little bit more simple to think about if you get used to using aggregates. So let's just say we're going to select the, well, first let's just do something like this. So let's just say we're going to select the year, because I think you can use that with order date, right? So here it gives me the year 2012. 2012, we have, we have different years here, 2013, and so on and so on and so on. So say we want to get that, and we also want to get the, like, let's say, what other information was there? So we're going to get the year. So you want to get the order number. So we say we want to get the number of orders by year. I was just trying to come up with an example and finally got one. So the number of orders by year, okay? So we have the year, so we just want to count the number of orders. So we just say count order number, and then we're going to say group by year, order date, because that is not an aggregate function, so we have to group by that. And then if we format it, so in 2013 we had 408 orders, in 2014 we had 270, and in 2012 we had 152. So again, how would we turn this into an analytical function to be able to get all of the information? So we can do something like this. So we don't need to group by anymore. We'll keep the year, order date, and then here we're just going to say over, and then partition, which is like your group by. And what did we do? We did year, order date. Okay, so year, order date. Okay, so now if we do this, we have all of this stuff, which is just repeating here. But again, like I said, now that we have that, because it's giving us all the other records, we can get more information. So we can say, okay, in 2012 we had a total of 152 orders, and these are all the different orders. goes to 152. So let's say you want to even take this further. Say you want to do something like this. So I counted that. Say if I want to do like month here, and then here I want to say P, then month, then change that, format that, order date, that's right. Okay, so here I'm saying in 2014 I had 270, and in this month I had 2. But what would make more sense is if I did probably make more sense if you actually see the month. But here in February, in the different times of February, we had 83. Okay, and then if I can, is there any more February here? So you can just do stuff like that, and I can even take it further and do let's say, how can I do the year and the month? So in my partition, I want to say not just month, because month is kind of doesn't make any sense, because you can have a February in each year, so it's not really telling me much. So what I want to do is actually partition by the month and partition by the year. So now we have a grouping in both of those. So now if I look here, and here the numbers are changing. So I have 33, and as you can see, there is the January, which is the month of 2013. And then once I get past January, which if I keep going, I think I already passed it. So this is January 2014. So it's still in January, but it's a different year. So you can see the number change. So it went to 55. And if I go to like February of 2013, the number changes. So you can just get like so much more information when you start using analytical functions. And this is just kind of just touching on what you can do, but there's so much more. You can still add in like all of the stuff we've learned before, like where, let's say what do we have here? Where ID is greater than, let's say less than 10. That'll knock out a whole bunch of records. So now we have a lot less records, and here we're having you have your July of 2012. So everything here was saying that it was done in July. So let's just go a little bit more. So here you start seeing we have different ones. So here back in August of 2012, we only had 7 records, which is here. 1, 2, 3, 4, 5, 6, 7. And in July of 2012, we had 22, which if you were to look here, once we get to like 23, it should flip, which it did here. And so you can see you start getting so much more information. I know all of these are saying anonymous because I didn't give them like aliases. But you can start getting so much more information when you start doing like analytical functions. And you know, the sky's the limit, and it's not just like count or stuff like that. Let me also show you a different one, because I'm leaving out one main part of analytical functions that I should touch on. Let's just keep on the same example just to make this easier. Actually, let me find one that has less information. So this was one that I used, and I have a lot of results there. So I had 78 records here, all right? And so I was summing the unit price. So that'd be 59, and then I'm doing the over. So let's say, for instance, I wanted to do like a row number. And I'm saying, oops, I didn't mean to delete that. I'm saying over partition by supplier ID, okay? Oh, sorry. When you use the row number, which is the actual thing I want to talk about, you have to use an order. So let's say I'm going to order by supplier. What else do I have here? Can I order it by unit price? Unit price. Order by. Forgot to buy. Partition by supplier ID. Order by unit price. This is the keyword over. Did I forget the parentheses? I forgot the parentheses, so that's why that was failing. So you have your row number here. So see, let me just change this from some price so it makes more sense. Just say row number. All right, so here you have 1, 2, 3, and then the numbers. You start seeing the number just starts repeating. It starts at 1, 2, 3, then it goes to 1, 2, 3, 4, then it starts over again. So what's happening there? Why is that doing that? So we're getting a row number, right? And we're saying we're partitioning by the supplier ID. So these are my supplier IDs. So I have three records that has 1. And then when I do order by unit price, if I look at the actual unit price here, and for those 3, there's 10, 18, and 19. So what it's doing is giving that position 1, 2, and 3. Now, if I was to do this an opposite way and say instead of doing order by unit price, which is default to ascending, let's do descending. So now, if I were to look at these results, it has 1, 2, and 3. But as you can see, they flip. So now it's saying that it's going to look at the priority first for descending. So now 19, which is the highest price because it's descending to the lowest price, gets row number 1. And then unit price 18 gets row number 2. And then unit price 10 gets row number 3. And then here it was backwards because I did ascending. 10, 18, 19, 1, 2, 3. So you have aniseed with 1, chai with 2, chain with 3. And then here you have chain with 1, and then vice versa. And as you can see, once it gets to a new supplier, the count starts over. And this is the descending one, so we can say 1, and then 2, and then 3, and then 4, and then so on and so on and so on. So you can use stuff like this to start getting more information, and then start building complete data sets and records of what you want, not just what you see in the table. You can kind of make your own stuff. And then once you get to this point, when you start if you're at work and they give you okay, well, we need this to happen, you can sit down and think about it okay, can I do this in an aggregate? Okay, if an aggregate doesn't work, can I do this in an analytical function? If that doesn't work, can I do it a different way? So I'm going to release some more videos about this, and I'm going to go deeper about analytical functions because it does way more than this. There's also a recursion with analytical functions that does some really cool stuff. There's also outside of analytical functions, in the next video, I'm going to discuss CTE, which is called common table expressions, which does some really cool stuff. And there's a lot more I just want to cover, but I don't want to make it too long, and I don't want to make it too advanced for people that are beginners, because if you got to this point and you are a beginner, you probably got confused because I kind of went way past beginner. But with that being said, I'm going to go ahead and stop this for now. And I hope that you liked it. And again, if you're liking these videos, go ahead and subscribe and also hit that notification button. Okay, so peace out.